Hello everyone, thank you for joining me today in this session. So today in this session, we are going to begin solving this project, the C, malloc and free. In the previous video, I've given you an insight or overview of what malloc, free are, isn't it? We said malloc is simply a function that is used to allocate memory to our program dynamically. So it means malloc is going to allocate the exact amount of memory that our program needs to execute. Right? So it's not going to allocate less memory for the program, and it's not going to allocate more memory to the program. So as you can see, malloc is very important to avoid memory wastage and also memory shortage to our program. So it helps our program to acquire the exact amount of memory it needs to execute effectively and efficiently. And we've seen that the free function is used to free the memory that is allocated by malloc or malloc-like related functions, which are the calloc and realloc. So the free function is used to free those memories that are allocated by these functions. And why do we need to free the memory? Because if it is not freed, at some point, the amount of free space that we have will be exhausted from the heap. Okay, so thereby other programs will not be able to have access to those free memories. That's why it is important to free the memory. So today we are going to begin solving the tasks on this project. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to bitweblearn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX Complete C programming course. So because I'm already logged in, that's why I'm seeing continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access these more functions, more nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also, if you have a course that you want to sell on this website, you can register as an instructor. Simply come here and then you can click on instructor registration. You can register as an instructor. Because I've already registered, that's why you're seeing you are not registered as an instructor. In your own case, you'll see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. Before everything, what I did here is I already have my main.h. Let me give you an overview of it. So did you see that this is my main.h? I have all the functions for this particular project here inside. Okay, so I don't need to be switching from another file to the main.h. Okay, so I have everything here. All right, so let's begin solving examples. So let's clear. All right, so this example here says we should write a function that creates an array of characters and initializes it with a specific character. So the function should create array of character, right? And that array should be initialized with what? With a specific character. So this is a function prototype, and this is what an unsigned int size. So this is going to be the size of our array, right? And this char here, this parameter C here, will be the what? The specific character that will be assigned to the array. So it means that whatever is passed as the second parameter is what will be stored in this array, in the whole of the array. Okay, so we are going to return null if size is equals to 0, returns a pointer to the array, or null if it fails. All right, so let's open the file. This is it. So vi pastes. Let me zoom my screen a bit. Yeah, I think so. As you can see, I already have my Betty documented, so that I will not be wasting time writing Betty documentations. Okay, so that the videos will not be very long. Alright, so what's the first thing we need to do here? We've already seen that malloc returns what? A pointer. In the previous video, I've already explained to you that malloc returns a pointer, right? We said it returns a void pointer, right? A generic pointer. So, and for us to store that pointer, we need another pointer to store pointer, right? So for you to use malloc, you definitely need to what? Need to declare a pointer that is going to hold the return value of malloc. So let me declare a pointer and let me call it ARR for array, since I'm going to create an array, right? I want to allocate memory for array. All right, so here, what's the next thing I need to do? I need to allocate the memory now. I'll now say ARR, right? That's the pointer, right? So I'll just say malloc. We've said that we can typecast malloc depending on what you want to store in malloc. I can simply just say car, since I want to store car in malloc, right? Because this is what? A character. So what I want to store in the memory space that will be allocated to me by malloc is going to be a character. But like I said, typecasting is not compulsory. I can allocate memory like this without any typecasting and it will work. Okay, so after calling the function malloc, what else do I need to pass to it? I need to tell it the size of what I want to pass or what I want to store in the function. I want to store character, right? So I just say size of, and then I will pass in car. So it's going to get the size of character depending on your machine. You know that the size of character varies depending on the machine, right? So it's going to get the size of character in whatever machine this program is going to run. It's going to get the exact size of character. So that's why you cannot fix the value here. Okay, you cannot fix the value. So how many characters do I want to store? So we are going to fill what? The entire array with this character S. Sorry, C here, right? And what is the size of the array? The size of the array is here, size. So it means that if the size of the array here is 10, we are going to have how many characters stored? 10 characters. If the size of the array is 20, we are going to have how many characters? 20 characters. So how can I tell malloc the number of characters I want to pass? I will just pass what? I will just say size. That's all. So malloc is going to multiply whatever the size is with what? With character. So it's going to allocate the exact amount of memory I need to store my characters inside this array. Okay, also if we allocate memory using malloc, there are possibilities that malloc is going to return a null. And in what case is malloc going to return a null? If the memory in the heap is exhausted. So there is no free memory for malloc to allocate to our program. Malloc is going to return a null. So we need to pass a condition. Okay, we need to pass a condition. I need to say if ARR, that is ARR here is holding what? The return value of malloc, right? So if ARR is equals to null, that means if malloc returns a null, I'm also going to return a null. I'll just say return and then I'll pass in null here. So if malloc returns a null, my program is also going to return a null. Okay, so this is a very good practice. You need to always be considering this case. Okay, all right, so what's the next thing I need to do? I need to also check here. We are given a condition that if size is equals to 0, right? If size is equals to 0, we should return null. I think I can just do that here. After the declaration, I can just say if size, right? I can just say if size is equals to 0, right? I'm just going to return a what? What does the question say? Return null, right? If size is 0, so I'll just say return null. Okay, so I have this condition checked. So what's the next thing we need to do? So the next thing we need to do now is to what? Is to store this character here, C, inside the array we created, which is allocated by malloc here, whose space is allocated by malloc, right? So how do we do that? We need a loop, right? We need a loop, and for each iteration of that loop, we will store the character inside the index, inside every index of the array, right? We know that arrays are made of index, right? So what is the size of the array? The size of the array is given by this parameter size. So when we're trying to loop, what should be our condition to stop the loop? Less than size. So we cannot exceed size, right? So I will need a character here. Let me declare another character here, which I'm going to use for my looping. So I'm going to say I here. Sorry, another variable. All right. So here, what I'm going to do is I'll just say for I equals to 0. So what should be the condition? I less than size, because I cannot loop and exceed the size of the array, right? And why am I saying less than size? Because I'm starting from 0, isn't it? So and what? I plus plus. So what this is going to do is simply this. It's going to loop from 0 up to the size of the array, isn't it? And for each iteration, I want to store the character A. the character C in the array. This is just like creating a loop to store the characters, right? So I'll just say ARR is the memory that is allocated for us to store the array, right? So I'll now say ARR index I is equals to what? Is equals to C. So what this is going to do is simply iterate over the array, right? So for I equals to 0, ARI is what? AR index 0. So it's going to go to index 0 of ARR. And this index 0 of ARR, or the memory for ARR, is allocated to us using malloc, right? So it's going to go to index 0 of ARR and store the character C here. This is the constant character that we are asked to store in the array, a specific character, right? So if I moves to 1, ARR1 is what? Index 1, right? That is AR index 1 of AR. It is still going to store C. I moves to 2, it's AR index 2, it still stores C inside AR index 2 until this condition becomes false. Okay, so if the condition becomes false, what should we do at the end? We are just going to return the allocated memory, a pointer to the memory. It says return a pointer to the array, which is what? ARR. This is the pointer to the array we created. So here I will just say ARR. That's all. Okay, I believe this is clear, right? So let's run Betty on this. So if I say Betty 0, okay, white space line 19 and 26. All right, let's see. Line 19 and 26. Where is 19? Okay, yeah, there is white space, and also 26 there is also. All right, so let's run again. All right, so Betty is fine. So let's copy the test file. Copy this. So vi 0 main.c, right? So paste I. All right, so let's compile the program and let's see if we will get the desired output. So paste. Wow, so it says what? Null undeclared. So it means we need to include our stdio.h, right, for us to use null. Also, what again? Malloc. So we've not included the header file for malloc as well. So for us to use malloc, we need to include what? The stdlib header file. So I'm going to do all these things inside my main.h so that I will not be including them on every file in which I'm working on. So stdio.h for the null character, and then for the malloc function, it's going to be stdlib.h. Okay, all right, so I believe this is clear now. So let's run it. Okay, what again? Comparison between signed and unsigned integers. Sorry for that as well. So here, as you can see, the character in which the variable in which I'm comparing this I with, I less than size, is what? The data types are not the same. I here is holding what? An integer, and then size here is what? An unsigned int, right? So I need to make my I an unsigned int as well. So what I'm going to do here is say unsigned int I. So that's all. Problem solved. All right, so let's run compiler. As you can see now, it's worked. So let's run the program. All right, so as you can see, we got the exact same output here. So I'm sure you'll be wondering why I've not used the free function in my function. Let me open my file. I've not used the free function. Let me open it. So as you can see, there is no way in my function I use the free function to what? To free the memory that is allocated for us using malloc. And the reason is simply because the function has been freed here. Okay, it has been freed here. If you understood what this test file does, you understand what I'm trying to say here. The function has indirectly been freed here. That's why. If it wasn't freed, the checker will fail. Okay, so that's why I don't mind freeing the memory here. Okay, so I think this is very clear. So we're going to stop here. In the next video, we are going to continue from task 1 of this project. So thank you very much. Till meet in our next session.